Good morning, scholars. I hope you are doing well. Welcome to our April 23rd application problem. So this is Thursday's application problem, but as you know, you're welcome to do this early. So I'm hoping that, this video helps you whenever you're doing it. So the question reads, Jose A wants to build a structure that will have a volume of 12 cubic units. Come up with at least 3 different structures he can create that will work. So when I'm reading this, I'm thinking, okay, well, what are some of the things I need to know? Well, it says that he needs to create a volume of 12 cubic units, a structure with a volume of 12 cubic units. So I want to remember that volume is the total amount that a item can hold, right? That a 3D object can hold. So in this case, it's like a cube because we're looking at cubic units. And we've been working with cubes. So in this case, the total amount that a, let's say a box can hold, right? It's actually anything that has depth inside. So in this case, right, with a cup like this, it would be what can fit in here to totally cover, go all the way in and fill it without going above it. So with this, that it's the total amount that some structure can hold. So when I'm thinking about this, since Jose wants his volume to be 12 cubic units, that means the total will be 12 units. That means we need to think about a structure that can hold up to 12 cubic units. In this case, 12 of those little boxes, right? Those little cubes that we used to work with in class. So in this case only, the volume needs to be 12. So I need to come up with a structure. Actually, I need to come up with 3 structures where the volume is 12. That means that if I have a cube like this, right? I'm looking at 3 things. I'm looking at the, actually do it like this. I'm looking at the length. I'm looking at the width, which is the part here that sort of goes back and forth. And I'm looking at the, let me do that better. I'm looking at the height. Bring this out. And, right, so we have width that goes across, length that goes up and down, and height that goes, length that goes across, width that goes back and forth, and height that goes up and down. So let me grab this. Here we go. Right? Length, width, height. And the total amount that fits into this structure needs to be 12. So if I'm thinking about this, if there's 2 ways to think about it. One is you can create an actual structure that has 12 of these little cubic units. So I could do 1, 2, 3, 4, 5, 6, and I'm actually just going to use a shortcut here, 7, 8, 9, 10, 11, 12. So this here, this has 12 cubic units. And if I think about it this way, I can actually count them. I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this structure, if we imagine this to be like actually one whole box, then it fits exactly 12 of these. So it does have a volume of 12. And when I think about it this way, what's the length of this structure, this specific structure? It would be the length, spelled that wrong, length is 12, right? Because the length is this across amount, 12. The width, back and forth, well, it only goes back 1. So it's 1. And the height, how tall it is, again, it only goes up 1. So length of 12, width of 12, height of 12, that would work. let's think about another structure. This could be one of Jose's structures. Let's say I did one that had only a length of 3. Let me move this a little closer. I had a length of 3, but what if I started building it up, right? And now it had a length of 3, but it had a height of 4. Well, now I have, let's count the cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, I've come up with a volume of 12, but it's a different looking structure because, again, volume has to do with the amount of cubes that can fit into the structure. So in this case, there's 12 cubes that can fit into this. In this case, there's also 12. Yes, they look different, but they have the same volume. And let's think about it, right? So in this case, the length of this one is only 3. The width of this one is still 1, but now the height is changed. Now the height is 4. And so if you remember our calculation, our equation for volume is length times width times height. So if we do this, 12 times 1 times 1 is going to be 12. 3 times 1 times 4 is going to be 12. So another way to do this, if you're still with me, awesome. Another way to do this, yes, you can, right now we've created 2 structures. We need to come up with 3. Now you can keep making like individual cubes to show this, or you can actually just make one giant cube, like what I have here. Sorry about that. And I can tell you, rather than building out the individual cubes, I can tell you what the length, width, and height is. So for this one, let's say I said it had a length, and remember it has to be a different structure from the ones I built before. So let's give this one a length of 4. Okay, now 4, let's give it a width of 3. I'm just going to grab this, move it over, and let's give it a height. Well, let's see what we have so far. 4 times 3 is already 12. So I've reached my capacity, so that means that I can't make the height anything that will change that number. So my height is going to be 1. The reason I need my height to be 1 is because if my height was 2, let's say, then it would be 4 times 3 times 2, and that would be 24. It would not be 12. And remember, I need my volume to be 12. So there's 2 ways that you can do this. You can either draw out your individual cubes, or you can just draw one large structure and label your height, width, and length. But either way, what you're looking for is for your volume, which is length times width times height, to equal 12. So you need to make sure after you've done it, whatever it is, you need to make sure that your volume is 12. And since it's 3 different structures, you can't have 3 that look just like this, or just like this, or just like this. You need 3 with different dimensions. Their volume, however, needs to stay the same. If this was confusing at all, because I know that this is a new concept for us, please come to office hours. That's what we're here for. We miss you, we love you, Miss Andrea and I, and we would like to see you there. So we hope to see you. Bye, scholars.